Hello, everyone. Welcome back again to part two of 2.5 Exponent Laws 2. This time we're going to define fraction or slash quotient to power law. Okay. In other words, the base of a power, it can be a fraction or a quotient. Okay. So we'll demonstrate this by example. Okay. And I guess I should write the instruction here. Write as power. Okay, so when you get a question that says or asks you to write it as a power, then it just wants you to write it as a power with a base and an exponent on it. You don't have to calculate it yet. When they ask you to evaluate, that's when you calculate it, type it in your calculator and get an answer. Okay, but this first example, we'll write this as a power. So let's say you have a fraction 5 over 6. This will be our base, and we're going to give it an exponent of, let's say, 3. Okay, and again, we're just going to write this as a power. But first, at the same time, we're deriving or defining what fraction quotient to power law is about. Okay, so now what I'm going to do is I'm actually going to write this power as a repeated multiplication. Well, what is that going to look like? Well, take 5 over 6 and you're going to multiply it to itself 3 times, like so. Okay, and now look, I want to rewrite this back as a power. Well, this actually looks like you're just multiplying some fractions, right? Well, in that case, well, multiplying fractions, just multiply the numerators and then you multiply the denominators. That's what multiplying fractions is about. Okay, so now I'm going to rewrite this as a power. Well, this is 5 times 5 times 5, and I'll give us 5 to the 3. This is 6 times 6 times 6, so that'll give us 6 to the 3. And this is how you write it as a power. Okay, and so if you look at the original power that we have here, essentially, can you tell me exactly what is it that I just did with the exponent? Well, it looks like all I did was really apply this exponent to both numerator and denominator. Okay, there's another way that this power could look. Let me give you another example here. It could also look like this. If we have 4 divided by 2, this to the power of 3, we use exponent 3 again. What is this going to look like? Well, it's a repeated multiplication. 4 divided by 2 times 4 divided by 2 times 4 divided by 2. Now, honestly, there is no way for me to get around this but rewrite this as a fraction again, okay? Because essentially this 4 divided by 2 is actually 4 divided by 2. And 4 divided by 2 is actually essentially, because you know that that's what a fraction is. It's the top divided by the bottom times 4 divided by 2. Okay, and look, it looks like the same as our previous example here, where we had repeated multiplications again of 4 times 4 times 4, which is 4 to the 3, and then 2 times 2 times 2, which is 2 to the 3. And if I really want to rewrite this back as a quotient or a division looking, then this is what it's going to look like. And look, do you notice what happened from here to here? Well, if the base is a quotient, then all I really did was apply this exponent to each of these items in bracket. In other words, the dividend and the divisor. Okay, so now this exponent applies to this 4. We got 4 to the 3 divided by this exponent applies to the 2, and we got 2 to the 3. So basically, what is fraction quotient to power law? Well, all it is apply the exponent to both numbers, okay, numerator, denominator, both the dividend and the divisor and the quotient, okay? So let's try to write out this law, okay? So the fraction slash quotient to power law states that when the base of a power is a fraction or quotient, but I don't want to have to rewrite one for a quotient either, comma, the exponent applies to numerator and denominator. Okay? And that's all it really is. Okay, I can also rewrite this as when the base of a power is a quotient, then the exponent applies to both dividend and the divisor. If you want me to do that, okay, I can do that. Um, but actually, maybe we will in the next definition. But they're one and the same. They're basically the same. Okay, so in other words, in a over b, all this to the exponent of, let's say, n. This is really equal to a to the n over b to the n, okay, where b cannot be equal to 0, okay. It could also look like this if it was a quotient. A divided by b to the n is actually equal to a to the n divided by b to the n, and again, b cannot be equal to 0, okay. This is just a general formula or statement for it. A and b are integers. Again, always except 0. Okay. Okay. Can't have you can't have a basis 0. This is 0. Okay. N is any whole number. Yes, whole number. In other words, at this grade level, all we're doing really is we're not doing negative exponents, even though I think I can show you what that actually looks like. I think I might still upload a video where what negative exponents look like, and it's really very simple. Okay, so now let's try a couple of examples where we actually have to evaluate this. So evaluate, okay, and in this case, you got to make sure that you actually have your calculator handy, okay? And I have 3 different calculators here. I'm going to show you what the exponent button actually looks like and how we're going to do this, okay? Let's say our first example is 8 over 2, all this to the exponent of 2. Okay, so in this first way that I'm going to evaluate, I'm actually going to apply this exponent to both top and bottom here, numerator and denominator. Okay, so 8 squared over 2 squared. Okay, and then I'm going to do this. I'm going to show you, I'm going to demonstrate this to you in the calculator what 8 squared is. Okay, and this is the exponent button right here. And this calculator is called a Casio, FX260 Solar 2. The exponent button is right here. It's this guy, okay? XY, X to the Y, okay? And another calculator that I have, the exponent button is actually this button right here. So focus the y to the x. And yet another calculator that I have, the exponent button is this guy right here. Okay, it looks like it's just you know, an arrow kind of thing. So you can use any of those to do your calculations with exponents. Okay, so I'm going to show you how to use this, how to do 8 squared. So first you type in 8. Okay, see that, and then I'm going to press this x to the y button. Okay, and that'll tell me, hey, what exponent do you want this 8 to be in? Well, and then I'm going to press the 2. So, and then you just press the equal sign. And I got 64. Okay, so that's just demonstrating for you how to use this, some of these buttons in your calculator. And 2 squared, I guess we don't need to type that in the calculator. So that'll be equal to 4. And then finally, 64 divided by 4 is 16. Okay. Now, some people might ask, do you always have to apply that exponent first before you to solve this and do this evaluation? Actually, no, you don't. In this case, there is no rule against you doing a division first inside the bracket, because as far as orders of operations or bed mass, it states that you're really supposed to do the brackets first anyway. Correct? Yes. So if you did do this division, 8 divided by 2 first, then you're going to get a 4. And that 4 is going to be the exponent of 2. Well, actually, this is actually much easier, is it not? And there you go. That's an example in evaluation. Okay? One last one. Okay? What if you have 9 divided by -3, all this to the exponent of 3? Again, you can do it 2 ways. Apply the exponent to both first, okay? And then do the division, okay? In this case, let's try using this calculator this time to do this calculation, okay? So let's see, 9 to the 3, I'm going to press 9, and then I'm going to use this button here, this triangular looking or peak or tent looking button, which is actually an exponent button. And that's going to be exponent 2. And of course, that's going to be 81. Oh, pardon me. Sorry. It's supposed to be to the 3. I got to redo this. 9 with exponent of 3 is going to be 729 divided by -3. Now, here's how you do a negative, okay? Type in this 3. In this case, in this calculator, I actually have to type in this negative first. This is a negative button right here into the 3. So there's my base. And now I'm going to put that to the exponent of 3. And I'm going to get -27. And finally, 729 divided by -27 is -27. Now again, on this side, I'm going to show you, do you really have to apply that exponent first? No, you don't. Okay, so you can go ahead and do the division first if you want. 9 divided by 3 is -3. All that to the power of 3 will give you -27. So you can do it either way when they ask you to evaluate. When I ask you to write an answer as a power, then they just want you to do this, okay? As a power, evaluate, okay? So hopefully this video helped, and I wish you all luck, and stand by for part 3 of exponent laws part 2, which is going to be, I believe, power to power law. Have a good day.